Class 11 Chemistry, Chapter 2 Structure of Atom. Hello students, this is your chemistry ma'am Archita ma'am. Today in this presentation I am going to discuss structure of atom. First one we would discuss electromagnetic radiation. The first figure you can see, when electrically charged particle moves under acceleration, alternating electrical and magnetic fields are produced and transmitted. These fields are transmitted in the form of waves called electromagnetic waves or electromagnetic radiations. Now, there are some properties of this electromagnetic radiation. The oscillating electric and magnetic fields produced by oscillating charged particles are perpendicular to each other, as you can see from the diagram. And both electric and magnetic fields are perpendicular to the direction of propagation of the wave. Unlike sound wave or water waves, electromagnetic wave do not require medium and can move in vacuum. There are many types of electromagnetic radiations which differ from one another in wavelength. These constitute electromagnetic spectrum. The band of electromagnetic spectrum is being shown in the slide. Different regions of the spectrum are identified by different names. The examples are radio frequency region, used for broadcasting, microwave region, used for radar, infrared region, used for heating, ultraviolet region, a component of sun's radiation. A small portion is of visible light. This visible light is the only part which our eyes can see. Special instruments are required to detect non-visible radiations. Different kind of units are used to represent electromagnetic radiations. These radiations are characterized by the properties, namely frequency and wavelength. Photoelectric effect. H. Hertz performed a very interesting experiment in which electrons were ejected when certain metals, for example potassium, rubidium, cesium, etc., were exposed to beam of light. This phenomena is called photoelectric effect. As you can see from this slide, energy which is equals to hc by lambda, that energy is required to remove the electron from that shell. So results of the photoelectric effect experiment where the electrons are ejected from the metal surface as soon as the beam of light strikes the surface. That is, there is no time lag between the striking of light beam and the ejection of electrons from the metal surface. Now the number of electrons ejected is proportional to the intensity or brightness of light. For each metal, there is a characteristic minimum frequency, below which photoelectric effect is not observed. At a frequency below threshold frequency, higher than threshold frequency, the ejected electrons come out with certain kinetic energy. The kinetic energies of these electrons increase with the increase of frequency of light used. So we can say The kinetic energy of the electrons is directly proportional to the frequency of the light used. Next, we would discuss Bohr's model of hydrogen atom. Niels Bohr was the first to explain quantitatively the general features of hydrogen atom structure and its spectrum. Though the theory is not the modern quantum mechanics, it can still be used to rationalize many points in the atomic structure and spectra. Bohr's model for hydrogen atom is based on the following postulates. The electron in the hydrogen atom can move around the nucleus in a circular path of fixed radius and energy. These paths are called orbits. Stationary states are allowed energy states. These orbits are arranged concentrically around the nucleus. The energy of an electron in the orbit does not change with time. However, the electron will move from a lower stationary orbit to a higher stationary state when required amount of energy is absorbed by the electrons or energy is emitted when electron moves from higher stationary state to lower stationary state. The energy change does not take place in a continuous manner. The frequency of radiation absorbed or emitted when transition occurs between two stationary states that differs in energy by delta E is given by nu equals to delta E by h. And one more postulate, it was the angular momentum of an electron in a given stationary state can be expressed as mvr equals to nh by 2 pi. The energy level diagram for the hydrogen atom is being shown in the slide. You can see if the d excitation that is coming from higher orbital to lower orbital is 1, means when the electrons are coming to one number shell, then it gives to the Lyman series. When it is in second number shell, when it is coming, then it is Balmer series, and when it is coming to third number shell, it's Pascal series, and when it is coming to fourth number shell, it is Brackett, and fifth one Pfund. For the calculation of the wave number, the equation is given in the slide. Next, we would come back to drawbacks of Bohr's model. That is the limitation of the Bohr's model. It fails to account for the finer details of the hydrogen atom spectrum observed by using sophisticated spectroscopic technique. Bohr's theory was also unable to explain the splitting of spectral lines in the presence of magnetic field, which we can say Zeeman effect, or an electric field, that is Stark effect. It could not explain the ability of atoms to form molecules by chemical bonds. In other words, taking into account the points mentioned, one need a better theory which can explain the salient feature of the structure of complex atom. So different theories were made after that. Now we would discuss this dual behavior of matter. De Broglie, was a physicist, proposed that matter, like radiation, should also exhibit dual behavior, that is, both particle and wave like properties. This means that just as the photon has momentum as well as wavelength, electrons should also have momentum as well as wavelength. क्वांटम मैकेनिक्स के अकॉर्डिंग जैसे कि हमें पता चला फोटॉन का वेवलेंथ और पार्टिकल दोनों नेचर होता है, वैसे ही इलेक्ट्रॉन का भी पार्टिकल और वेवलेंथ दोनों ही नेचर होना चाहिए. सो डी ब्रॉगली lights upon this theory. He has given the relation between wavelength and momentum. The equation is being shown. Lambda is equals to h by mv, which is equals to h by p. So it's equals to p is the momentum, and if the momentum is converted into kinetic energy, then the expression changes to h by root over 2 mqv. De Broglie's prediction was confirmed experimentally when it was found that an electron beam undergoes diffraction, a phenomenon characteristics of waves. This fact has been put to use in making an electron microscope, which is based on the wave-like behavior of electrons, just as an ordinary microscope utilizes the wave nature of light. An electron microscope is a powerful tool in modern scientific research because it achieves a magnification of about 15 million times. So, according to de Broglie, every object in motion has a wave character. The wavelength associated with ordinary objects are so short that their wave properties cannot be detected. The wavelength associated with the electrons and other subatomic particles can, however, be detected experimentally. तो बॉडी का साइज अगर इंक्रीज होता है तो उसमें वेव नेचर देख पाना बहुत मुश्किल है. अगर बॉडी का साइज छोटा है तो उसमें वेव नेचर देख पाना ईजी है. नेक्स्ट वी वुड डिस्कस हाइजेनबर्ग्स अनसर्टेनिटी प्रिंसिपल. According to Heisenberg, it states that it is impossible to determine simultaneously the exact position and exact momentum of an electron. The expression of the Heisenberg's uncertainty principle is given in the box in the slide. If the position of the electron is known with high degree of accuracy, then the velocity of the electron will be uncertain. If the velocity of the electron is known precisely, then the position of the electron will be uncertain. Thus, if we carry out some physical measurements on the electron's position or velocity, the outcome will always depict a fuzzy or blur picture. Significance of uncertainty principle. Important implication of the Heisenberg uncertainty is that it rules out existence of definite paths or trajectory of electrons and other similar particles. In everyday life, the objects are not so small size and they do not have high velocity also. Hence, the momentum and position can be determined with accuracy. For example, football or cricket ball, the momentum and position can be easily found out. That's why in everyday life, the Heisenberg's principle has no significance. But for the very small particles like electrons, protons, and these subatomic particles, the Heisenberg's uncertainty principle is very much of significance.